Hello and welcome back. I'm Navneet Kataria, Product Marketing Engineer with Anritsu on VNAs. So today we are going to make some mixer measurement. This is the mixer and the specification for this mixer is RF or LO can take 2 to 18 gigahertz and the IF operation is from DC to 750 megahertz. I will be displaying the graph and measurements of this mixer as per its technical data sheet, and then we will compare it with the measurements that we are making today. So for doing the mixer measurement, only conversion loss, what you basically need is a VNA, which we have here as the 40 gigahertz VectorStar. Then for the LO, you also need to have a signal generator. Now this signal generator can actually go up to 20 gigahertz, but we have models going up to 70 gigahertz and beyond. So what we'll do now is I will run you through the mixer wizard that we have, and it's pretty straightforward as far as the using of the mixer wizard is concerned. So we go on to applications, we go to mixers, and then we go to mixer setup. And here you can see that you can configure the sweep type as frequency sweep, linear, log, or you can do a power sweep. You have the option of reversing the IF, and now you can configure the ports like RF port as port number 1, or it could be port number 2, anything, right? So right now I am configuring RF to be port 1, IF to be port 2. So you can see this is going to be the RF, this is going to be the IF, and this is going to be the LO, which is coming from here on the signal generator. Now what we'll do is we'll first have to select the external source, and for that you need to check the GPIB settings. The GPIB settings, the address on this guy and this guy should be the same. I have already done that, and I will in the video I will show some pictures as well how to configure that. There's a 10 megahertz reference locking for these two, and then we have a GPIB connection also going at the back. So now that we have done the setup, let's configure the x-axis display to be the IF, because that's much easier to see. Now we go on to setting the frequency. It says that external source 1 is not on, so that means the GPIB is not set. So let's see which one is there. The LO frequency is out of range. Yeah, we need to set the frequencies. So what we do here is once the unit is configured, we see the RF frequency, and we can go say from I can go from 2.1 gigahertz as the RF, 2.1 gigahertz to stop as 4 gigahertz. And on the external, I want the LO to be fixed, so I do that as 2 gigahertz. And once 2 gigahertz is done, I do the IF to be auto, and then my wizard is gonna do the calculations automatically. The IF is RF minus LO, which is the USB, and that is what we are interested in. So I press OK, and now I get 100 megahertz to 2 gigahertz of the IF. So this is how you need to configure. Now since mixers are frequency translating, or the input frequency is not equal to the output frequency, so the vector network analyzer needs to be equipped with an option called as frequency offset or the receiver offset, because the receiver is working at different frequencies, right? So you need to have that option installed in the VNA. Once we are set for the frequencies, now you can see in this diagram we have the port 1, which is RF, so 2.1 gigahertz to 4 gigahertz. The external source is already locked, and you can see that the display updates are off, and you can see a remote connection here. The external is 2 gigahertz, and then the IF is going to be 100 megahertz to 2 gigahertz. Although the specification for this mixer is 750 megahertz, but I want to show you the roll-off and the performance of this mixer beyond the 750 megahertz IF frequency. Now the next step is to set up the power levels. So on the RF side, I want to go for 0 dBm, and for the mixer we go for plus 10 dBm. For the LO, we go for plus 10 dBm, and then I press OK. And once I'm done, you can actually import some channel setup as well if you already have created one or you have one. So you just need to import the frequency plans, etc. Once the settings are done, you just have to click done, and now the next step automatically comes into action. It says that setup completed and validated. Please proceed with the appropriate calibration and measurements. Would you like to start a power cal? Now power cal is important because now what we are doing is we want to make sure that whatever power is coming from port 1 and going inside this mixer, we want to be very sure that it's accurate, because at the end of the day we are seeing the conversion loss, right? So let's just connect this power sensor. So all our VNAs, they select power sensor calibration right up to 110 gigahertz and beyond. So let's just connect that, and I'll use a torque wrench to tighten that. Okay, so this is connected, so I say yes. Now what happens is that it should calculate the frequency plan, and now it says that you need to calibrate the source. So we are using a USB power sensors. The number of points, I've deliberately kept it to 201 because I want the resolution of the power to be good. So it's gonna take a little time, but then it's always good to have more power calibration going on. Apart from this normal scalar conversion loss for the mixer, we can also do a group delay kind of vector mixer measurement with another technique which we call as N by N, in which we actually use 3 mixers to characterize each one of them, and then we make one of them as the reference mixer. And then for the actual DUT, we de-embed it from the measurement, and then we can get the group delays, etc. for the test mixer. So if you are interested to see how the N by N or the reference mixer approach works on the vector network analyzer, please let us know, and we would love to have that video done as well. So now you can see that the USB power sensor has already almost completed 70% of the power calibration. So once the power cal is done, there is a provision of saving this power cal as well, so that every time the customer wants to repeat the test, he does not need to spend a lot of time in doing the power cal again and again. So you can save that if you want, and once that is done, it's good enough. The next step is to actually transfer this power accuracy or do a normalization of the port 1 to port 2. So at least as far as the power is concerned, the port 2 actually knows what power is coming. So now you can see that it's done. So I click close, and now the next step automatically comes into action, and it says the power calibration is completed. Now you should do a receiver calibration or a normalization or an enhanced match calibration as well. So these two are actually basically kind of calibrations. Right now I'm just doing a normalization, a receiver cal, because we are just interested in seeing the conversion mixer loss. But in case you have DUTs which are not properly matched, then you can actually do an enhanced match calibration, which adds in a little steps, but then the ripples in your mixer response are gonna be taken care of. So right now we just do a receiver calibration, and this is how it's done. So you can modify the cal if you want. So yes, we are transferring the power accuracy from port number 1 to port number 2, and you can define the through definition. In our case, it's like 15.82 is the length of this through. So I do that, and I press OK, and then I go back and I do a through. So through happens pretty straightforward, and it just does the power accuracy. So once that is done, we are good for the measurement. You click done, and then what happens is that this display comes on the on your device. Now the thing is that it is basically not an S21 measurement, because this is working at different frequencies. So we have to response which is B2/1, because again it's working on a different frequency. So we go here on the response. We first do a log magnitude, then we go to response. Instead of B1/1 A1, I do B2/1. Yeah, so this is the response that we are getting, and this actually matches with the response that we have from the technical data sheet of this mixer. And you can see that roughly around 1 gigahertz. It's like dropping down, and that is what you should be able to see on the technical data sheet. So this is how a mixer conversion loss measurement is done using vector network analyzer, a signal generator, external signal generator. We have option in which we can actually have dual sources inside the same vector network analyzer, and actually you can do make use of that second source as the other source for the mixer LO, and then you can make your measurements. So yeah, if you want to see more mixer measurements end by end, just let us know, and we will try to do more videos for you. Thank you again for watching.